Welcome to I Can Know the Truth. My name is Ryan Conlon, and today I'm introducing my theory of everything called CFEP. It's the Complete Free Energy Principle. The free energy principle was originally developed by Carl Friston, and basically his is all about minimizing surprise and minimizing complexity. And so basically, I added a third cost, which is ambiguity. And so how this works is, first of all, I'm gonna start off, this video is just gonna be intuition. So I think the best place to start for intuition with these three, to show how they're distinct, is to show the three primary memory types. And that's procedural memory, semantic memory, and episodic memory. So procedural memory goes with prediction error minimization, minimizing surprise. Semantic memory goes with complexity minimization, and episodic memory goes with degeneracy minimization. And so yeah, degeneracy minimization is the ambiguity cost I was talking about. So some more associations that are really valuable are the law of identity goes with complexity minimization, non-contradiction goes with prediction error minimization, and the law of excluded middle goes with degeneracy minimization. So I'll say a little bit about, okay, here's another set of associations. So complexity minimization goes with your memory. Prediction error minimization goes with your expectation. And then degeneracy minimization goes with attention. Some other concepts would be consistency goes with prediction error minimization, coherence with identity, and completeness with degeneracy minimization. So there are lots of other associations, like following that triple. But there's another really important one, which is syntax and semantics. So basically, syntax is really prediction error minimization mostly, and also complexity minimization. Really, to be truthful, every single thing that exists involves all three to some extent. But there's a very clear as day association with syntax and rule following and sort of automaticity, and also basic perception and sensation. That goes with prediction error minimization and stuff. And then semantics goes with degeneracy minimization and complexity minimization. So I think another really good intuition is the physics. So basically you have kinetic energy and potential energy and action. And so this is all about paths. And so the principle of stationary action says that an object tries to take the most coherent path. And so, but it's non-local. So that's really degeneracy minimization. The fact that it's it's a non-local effect. That really consciousness is non-local a priori. It's you're one whole. You experience multiple things at once, and that's degeneracy minimization. One way it's preventing conflation. It's two paths are approaching each other to where they would degenerate, and it won't allow that to happen. And the closer you get to it, the more ambiguity, and so the more ambiguity cost there would be. And so yeah, basically it would be spiked to infinite if things actually collapsed into total and true information loss. So that gives a lot of cool physics intuitions, and really explains like a lot of quantum mechanics intuitively when you start to think primarily in terms of what needs to happen in order for information to be conserved. Because really the only two laws are, well, I guess really the law is conservation of information. There has to be truth. So, but also, here's another interesting condition. It has to be, in order to know the truth, there has to be a truth, but that truth, meaning the foundation that generated everything, it has to be conserved as well. And because of that, we know that it's maximally expressive. So whatever we can express, whatever we're ever going to be able to express, the foundation of reality, whatever it is, generated everything that we can ever be aware of. So, so I guess I should then talk about choice. So yeah, this is all about choice. That's what degeneracy minimization is fundamentally. So yeah, it's an ambiguity cost. So it engages attention to make a choice regarding model selection. Or also like resource allocation. It engages more resolving power. But yeah, choice is needed a priori in order to have valid reasoning. You need to be able to at least consider the possibility of making an error. And you also have to be able to talk about counterfactuals. And so there can be no loss of expressivity, even though, because so you have to be able to talk about something that is impossible now, but at one point was, it just was possible for me to, okay, I'll do an example. B, A. I could have said A, B, but I didn't, and now it's impossible. So those kind of things, awareness of those things and knowledge of those things really requires degeneracy minimization. Yeah, so basically what's changed from the normal free energy principle to the complete free energy principle is completeness. Now we have completeness. And it's modal completeness. So basically it says that reality at any given moment it completely specifies everything that has happened and completely specifies, sorry, doesn't completely, it means everything that is still possible, whether it completely specifies it or not. But it wouldn't syntactically, it wouldn't, you know, because it's unbounded. It has to continue on forever. So, in order for us to know the truth, anyways, there can't be like some end of reality. So, okay, what are yeah. So I guess one really interesting thing I've been thinking about is strategies to highlight the ambiguity. Now that I've reframed it as ambiguity costs, it's a little bit easier to see and to differentiate it from prediction error minimization. But I can definitely understand why, for a long time, people haven't really realized that there's an important distinction here. So I think the best way that I've come across is reading backwards, but in a specific way. So what you would do is maybe reading a short story of a couple of pages or something. You want to read the first sentence first, but the last word of the first sentence first, then the second last, third last, and so on. Because this really messes with prediction error minimization and your syntax. And so what it will do is it'll really force you to engage degeneracy minimization and engage in a way where you can understand the sentence, understand the sentence's meaning. And so what this should result in is you basically semanticizing syntax. And you'll have to basically build sort of a model of the syntax which is more semanticized and more explicit, because normally it's a lot of automaticity in understanding that. So, but yet, here's why this works. If you just don't bite off more than you can chew and just pick, like I said, the first sentence, last word, what it'll really do is it'll tax your memory. So you'll have to, because you're not giving them enough meaning, you're at the end of the sentence, and then you're gonna have to like sort of store the words. You won't be able to collapse them easily. You'll have to like sort of overload your memory or something, and sort of view it as a whole. And anyways, as you get better at it, you'll definitely, well, once you understand that it's this semantic syntactic thing, and that degeneracy minimization is about model selection, whereas syntax and prediction error minimization is about structural compatibility and rule following and stuff like that, then I think it'll make a lot more sense. So I think that's a real rough intuition for now, and I'll keep posting and just keep posting and posting. And I'll show you guys some math and stuff. And yeah, this is not the full like breakdown or anything, but yeah, I'll keep posting.